My name is Vivian Wu, and my project is the development of chitosan encapsulated thyme essential oil as an alternative fruit fly repellent for household use. So, in today's world, more and more people have begun composting to reduce greenhouse gas emissions and landfills. As a result, fruit fly infestations have become a more prevalent issue. But fruit fly infestations cause unsightly scenes and pose health risks by passing foodborne germs. So, how can we solve this problem? People have previously used insect repellent sprays containing plant essential oils, but these sprays are of short effect duration and are not suitable for indoor fruit fly infestation control because they are aerosols and can easily contaminate nearby foods. So, in this study, I encapsulated thyme oil in a chitosan matrix to create a fruit fly repellent that allows for slow release to effectively control fruit fly infestations for a long period of time. So for my project, I first searched PubMed for a list of essential oils reported to have insect repelling effects. Then, for each of these essential oils, I tested them in a fruit fly repelling assay, which I will talk a little bit more about later. And after determining thyme oil to be the most effective essential oil, I determined the key parameters of the product to be repelling efficiency, which tested in the two-choice repelling assay, loading efficiency, which is what percentage of the weight of the product is the essential oil, and encapsulation efficiency, which is the percentage of the initial essential oil that is encapsulated in the final product. And then I optimized the product by testing different essential oils, essential oil, chitosan, and sodium tripolyphosphate concentrations, as well as different emulsifiers such as Tween 80 and Span 80. And the final product was created first through homogenizing a Tween 80 chitosan mixture with thyme oil. And chitosan is a natural polymer, and Tween 80 is a surfactant that helps to stabilize emulsions. And then the emulsion was added to sodium tripolyphosphate, and after the ionization gelation, through vacuum filtration, all of the liquid was removed, and the product was dried until the weight no longer changed. So in order to test the efficacy of the essential oils and later the efficacy of the product, I set up a two-choice repelling assay. And in order to conduct this two-choice repelling assay, first, for each essential oil, I filled 2 glass tubes with 1 tablespoon of Drosophila food media. And then in one tube, 2 microliters of the essential oil was placed on a 1x1 Kim wipe and hung inside a mesh bag and sealed. And this served as the experimental group. And then in the other tube, a clean 1x1 Kim wipe was hung inside a mesh bag, and this served as the control. And then the tubes were sealed with parafilm, and a cup pipette tip was inserted through parafilm for both tubes so that the fruit flies could enter the tube but were unable to exit. And then the control tube was placed on one side of the container, and the experimental tube was placed on the other side of the container. And 50 fruit flies were released into the box, and the top was sealed with plastic wrap, and holes were punctured for airflow. And after 24 hours, the number of fruit flies in each tube was counted, and the repelling index was calculated, where C is the number of fruit flies in the control tube, and E is the number of flies in the experimental group tube, as C minus E divided by C plus E. And the essential oil with the highest repelling index was selected for the product. And these are the results from the fruit fly repelling assay. And thyme oil, on average, performed the best out of every essential oil, even those that weren't generally recognized as safe by the FDA. And the 3 highlighted in on the right are the top 3 performing generally recognized as safe essential oils. And I decided to test these 3 essential oils further to confirm that thyme oil was indeed the best. And I only chose to proceed with those that were generally recognized as safe because the product will be used in the kitchen area. So those not generally recognized as safe wouldn't be a safe option. So I further tested the top 3 performing generally recognized as safe essential oils, which were citronella, peppermint, and thyme oil. And I tested each at 1 and 2 microliters, and as before, thyme oil was had the best repelling index of all of the essential oils. So to actually encapsulate the thyme oil, I chose to use chitosan since it has good biocompatibility and it's biodegradable, and it can cross-link with sodium tripolyphosphate, which allows for slow sustained release. And when measuring the encapsulation efficiency, as well as the loading capacity, I found that 2% thyme oil and 2% chitosan provided for the best product composition. And in order to be able to measure the loading capacity as well as the encapsulation efficiency, I created a thyme oil calibration curve. And then in order to actually measure the absorbance of the thyme oil to determine how much thyme oil was in the product, I took 10 milligrams of the product, put that in 1 molar hydrochloric acid at 95 degrees Celsius for 5 minutes, and mixed that with 0.5 milliliters of ice cold ethanol, and centrifuged that at 8,000 RPM for 10 minutes, and measured the absorbance at 270 nanometers in the supernatant to determine the thyme oil concentration. And this was the final composition and yield of the prototype. And at the bottom is an image of the final product placed in an organza bag in a petri dish. So the final composition was 2% chitosan, 2% thyme oil, and 1% tween 80. And tween 80 was the best surfactant out of all those I tested. I ended up testing tween 80, span 80, as well as tween 20. And both the encapsulation efficiency and loading capacity of the product were good. And I measured the thyme oil content over 6 weeks, and the repelling effect stayed constant at 100% throughout all 6 weeks. And the content of the product barely changed over the 6 weeks, which indicates that the product will likely be effective for much longer than 6 weeks. So through encapsulating thyme oil in a chitosan matrix, I was able to create an 100% effective, biodegradable, and environmentally friendly fruit fly repellent product. And further studies will be conducted to determine the long-term stability of the prototype, and I expect the long-term stability to be good considering the 6-week data. And additionally, although the current product showed 100% fruit fly repelling efficiency, eggs and larvae already existing in the compost bin may still develop into adult flies, and it is unclear if the product will kill eggs and larvae. So a further study is to set up assays to examine if the product can prevent egg and larvae from developing into adult flies. I also plan to conduct assays for more encapsulating materials, such as other natural polymers like agar, gelatin, and alginate, and investigate those to determine the optimal encapsulation for fruit fly repelling efficiency. Thank you for listening.